Welcome to yet another important session in quantitative methods. Here we'll discuss probability distribution. Specifically, we'll look at what is known as a normal distribution. A normal distribution. Now, to understand a normal distribution, you need to understand the characteristics of a normal distribution. There are about 5 characteristics that can be visible. Number 1, it is bell-shaped. Number 2, each side of the quadrant is 50% or 0.5. Number 3, the area under this graph is equal to 1. Number 4, these tails don't touch the base. Number 5, the sides are asymmetric. It means they are a mirror of each other. This side perfectly fits the other sides like a pie. The mean, the mode, and the median are all asymmetrical about the mean in the middle here. They are equal. So this is what we call a normally distributed distribution. So it is given by the formula Z is equal to X minus mu standard deviation over the root of a sample size if you're given a sample size, or Z is equal to X minus mu over the standard deviation. This is a formula we use when we are standardizing. That is the formula we use when we are standardizing. So to start with, it is imperative that you learn how to read these Z distribution tables. This Z is 1.23. How do we read the Z of 1.23? When you go to the table, you check under 1.2, then under 0.03. Where these two meet, that is where the reading will be. Under 1.2, the first two, under 0.03, the last number here. So this is the format that we use when you're reading the tables. So let's use this. Let's check where there's 1.2. It is here. And under 0.04, 0.03, it is here. So where are they meeting? They're meeting at a point 0.8907. So from Z, if we are reading, what we are finding inside here is called the probability. So the probability of 1.23 is 0.8907. But if I were to ask you that what is the Z for this probability of 0.8907, you would tell me that it is 1.23. You simply add 1.2 and 0.03, it becomes 1.23. All right. Now give me the Z, the probability of the Z 1.96, and give me from the probability to Z of 0.9800. If you don't have the exact one, you give me the closest possible. Let's do that simple exercise. So what is 1.96? Somebody to read and take us through. 1.96, what is the Z?
.9
So 1.96, we go to under 1.9 and 0.06 here. So it's 0.9750, isn't it? That is the probability of 1.96. If I asked you to give me the Z for 0.9750, you would still tell me it is 1.96. Even if I said 0.9751, the closest is still 1.96. Now tell me what is the Z for 0.9800. What is the Z for 0.9800? Quickly go inside the tables and check which one is closest or which one is equal to. Then when you're done with that, give me the Z for 0.8413. 8413. Give me the Z. I'm giving you the probabilities, so you check from inside the tables quickly. Give me the Z readings for that. Who has found 0.9800?
Zero 2.0.
2.0 what? 06. Let's check 2.06. Yes, it's close, but not the closest. The closest is 2.05 because this one is below by 2. This one is above by 3. Of course, both of them can be chosen, but the closest is 2.05. I'll give you a mark for that. How about 0.8413? What is the reading for 0.8413?
It's 1.00.
Good. 1.00. This one here, there's an exact figure corresponding to that. So the Z for 0.8413 is exactly 1, in short. So this is how we read from Z to P and from P value to the Z. So when we're reading from the Z, we're getting the P value. When you're using the P value, we're getting the Z. Okay, so now we're going to learn how to standardize. So we've talked about the properties of a Z-score. Asymmetrical, area is under is equal to 1. It's bell-shaped and they don't touch the base. Now we're going to look at the 3 rules, 4 properties when we are reading the Z. Number 1, you need to learn how to illustrate. This is illustration. Number 2, you need to learn how to shade. Whenever it's greater, we shade to the right. Whenever it's greater, we shade to the right. Less, shade to the left. Less looks like this. So that is step number 2. Step number 2, we need to learn how to shade. So what determines where to shade is basically the sign that we find. Greater, shade right. Less, shade to the left. Then standardizing formula. I already gave you the formula for standardizing. It is Z is equal to X minus mu over standard deviation. Then apply. By applying, whenever the shading is smaller than 100, this is a small shading. It doesn't cross the middle line. So whenever the shading doesn't cross the middle line, we subtract our answer from 1. Whenever the shading crosses the middle line, we read it directly from the table as it is. So yeah, shading to the right on both sides, except that this small shading is very small. So we're subtracting our answer from 1. We're also shading to the right here, but this small shade, this is a big shading, so we're going to read directly from the table if you're using the cumulative table. Both of them are less than because they're shading to the left. This is a small shading. To apply, we subtract our answer from 1. This is a big shading. To apply, we read it directly as it is. So I'm going to look at this example. Suppose our mean is 10 and our standard deviation is 3. Find the probability that x is greater than 16. So we're going to follow these rules together. Number 1, we want to find the probability that x is greater than 16. Number 1, illustrate. The 10 is the mean, it's always in the middle. The 16, we need to locate it. Is 16 more than 10 or to the left side of 10? Using a number line, 16 on the right is on the right side of 10, so we are putting it here. Then we put our divider, our line. Then the sign here, which is appearing here, says greater than. So the reason why we are shading to the right here is because of the sign, which is saying greater than. Now, that is step number 2, shading. Step number 3, standardize. This 16 here, how do we standardize it? How do we simplify it? The formula for standardizing this 16 is given by x minus mu over standard deviation. Our x is 6, our mean is 10, and our standard deviation is 3. So 16 minus 10 is 6. 6 over 3 is 2. So this 16 stands for 2 in the table. So when we go to our normal distribution tables, when we check under 2, 2.0 here, it is 0.9772. 0.9772. So what this means is from here to here, we have 0. Okay, what this means here is that from here to here is 0.9772. So remember from our application, we said if the shading is small, the answer we get, we subtract from 1. If from here to here is 100% or 1%, and from here to here is 0.9772, how do we get this small reading? We subtract our answer minus 1. So 1 minus 0.9772, we get our answer there. What are you getting? What are you getting? What are we getting?
0.028.
0 point?
0.0228.
Good. So that's this shaded region here. So if this is 97%, this is 2.2%. That is what it means. All right. So let's try this one here. Less than 5. X is less than 5. So step number 1, identify where the 10 is. The 10 is at the same point as 0. So 10 is our mean. Our standard deviation is 3. Then let's locate where the 5 is. We cannot put 5 here on the number line. 5 is on the left side of 10. So we identify our 5 here. Then step number 2, standardize. We can't read this 5 from the table. So we need to standardize this. Okay, before we standardize, we need to shade. It says greater than 5. Greater means shading to the right. So we're shading this side. Now already we're able to tell that this shading is greater than what? 0.5. So we're going to read direct from the table because all the readings from the cumulative side or the positive side of the table are more than 50%. So we need to standardize this 5. All numbers on the left side of the mean are going to give you a negative z, but it doesn't mean the probability is negative. It just tells you that you're on the negative side of the number line. So 5 minus 10 divided by 3 is negative 1.6666. You preferably round off to the nearest 2 decimals for you to read the normal distribution table. So negative 1.67, when you go into the table here, you look for 1.6, under 0.07, you find 9525. 9525. So this cannot be the reading from here to here, no, 95%. It should be the reading from here to here, the bigger one. So whenever you have a bigger reading, just know that you read it directly. So the reading greater than 5 is 0.9525. 9525. That is where the reading is. 9525. Okay. I want us now to try, somebody to try this one. X is less than 15. X is less than 15. Step 1.
If you put 10 in the middle,
10 in the middle, good.
and 15 on the right side.
And 15 on the right side.
And since this is less than, you shade on the left side.
Good. You put the divider, and we're shading on the left side because it says less until you can shade no more. Don't end here like others do. You shade until you can shade no more. So already you can tell that this is more than what? 50%. So the reading we're going to find, don't subtract from 1, read it as it is. Yes. Step 3, what do you do?
Standardize.
Good, we standardize. So we're going to standardize the 15. So it'll be 15 minus what?
Minus 10
Over what?
over 3.
Over 3. Good. What are we getting?
1.67.
1.67. Good. You round it off to the nearest 2 decimals. So when you read 1.67 from the table, 1.67, what is it giving us? The same one, 0.9525. 9525. So this one from here to here is 0.9525. So we don't subtract. It is going to be directly read 0.9525. Excellent. All right. So I want somebody else to try less than 8. Somebody else to try less than 8. Step 1. Sydney?
The mean is 10.
So the mean is 10. Put it here.
So we'll standardize first. We'll do 8 minus 10
Let's,
over.
let's locate where the 8 is. Where's the 8?
So the 8 should be less than 10.
Okay, on the left side here, right? You put the
Yeah.
divider and the 8 is here. Good. Then what do you do to the 8?
So since it's less than,
Where are we shading?
this is a less than, so we're shading the left side.
Excellent. We shade to the left. So what does this shading tell you? Is it smaller or bigger than 50%?
More than 50%. So we
So
need to subtract from 1.
good. The answer we get to subtract from 1. So how do we standardize this 8?
So Z is equal to 8x minus mean over standard deviation.
All right. So
So it's 8 minus 10.
Over what? 3.
Oh,
What are we getting?
it's negative 0.67.
Okay. So negative 0.67 is equivalent to what? To 8. Then what do we do? We read it. What is the reading for 0.67? 7486, right? Zero point 0.7486.
Yes.
So that is the reading. 0 point. So what do we do? We subtract, right? So x less than 8 would be 1 minus 0 point 0 point what? 7486.
7.
What are you getting?
0.2514. 0.2514.
Okay. So that is the probability. All right. Now, sometimes you'll be asked to find what is the value of x. What is the value of x for which x is greater than 2%? What is the value of x for which x is greater than 2%? So whenever you're given a percentage, you cut it off. So since it's greater, you remove it from the right side. If they said less than 2%, we'd have removed the 2% from here. So when you remove a 2% from 100%, what do we remain with? 98%, right? Which in decimal is 0.98. Now, already whenever you're given a percentage, they're asking you to identify the p-value to z. So we've learned how to identify the p-value to z. We know here there's a 10. So we need to know the x here that we are looking for. So 0.9800 is the probability. So we read from inside the table. So we already found that one. What was 0.9800? When we check inside the table, the closest value we found was what? 2.05. Remember, the closest value to 98% is 2 point what?
0.5.
Remember this, right?
Yes.
So how do we go to the standardization table? We say Z is equal to X minus mean over standard deviation. Our Z, we've just found it, it is 2.05. Our X is what we're looking for. Our mean is what? 10.
10,
And our standard deviation is what? 3.
3.
So try to cross multiply. Let's solve for X. Try to cross multiply. Let's solve for X. The application of whatever I've taught you now comes in a word problem like this one. A soft drink vending machine is set to discharge an average of 215 ml of cold drink. So the average is called our mu. So this is what we put in between here. And our standard deviation is 10 mils. So our standard deviation is 10 mils. You'll always be told that this follows a normal distribution. For normal distribution, you don't need to think twice. So part A, if 225 ml cups are used, what proportion of cups overflow? So overflow is a synonym for greater than. So identify where 225 is, you put it on the right side of 215. You shade to the right. Why? Because of overflow. Already we can tell that this is a small shading. So step 1, illustrate. Step 2, shade. Step 3, standardize. So when you standardize this one, it will be 225 minus 215, which is 10. 10 divided by 10 is 1. So the mean is always equal to 0. This one, we standardize, this is 1. So in checking the table, 1 is equal to 0.8413. So from here to here, it's 84%. So when subtract it from 1, you get 0.1587. So this is a small reading remaining there. Part B, what is the probability that a cup contains at least 200 ml of cold drink? So at least means greater than. So 200 is on the left side of 215. When we put it here, we are shading where? To the right. We're shading the right because at least 200 means shade right. We can tell this reading is bigger than 50. It crosses the middle line. So when we standardize, we read it directly from the table. So when we standardize 200 minus 215 over 10, we are going to get 1.5, which we are going to read from the table. And the 1.5, if we read it from the table, you will get the exact value that you will need to without subtracting. So for this one, the last part, what size of cups ought to be used? If it's desirable that only 2% of cups overflow, you cut off the 2% on the right side because it's overflowing. If it's underflowing, if there's such a way to have cut from the left side, but your Z should have been negative because all Z's on the left side of the mean are negative. Here we're cutting 2%, we remain with 98%. When you check it from inside the table, 98 or 0.9800 is equivalent to 2.05. So we know that standardizing Z is X minus mu over standard deviation. Where there's Z, we put 2.05. Even if you put 2.06, it's also close, you'll be given a mark. Our X is what we're looking for. Our mu is 215 and our standard deviation is a 10. And like I have taught you, you calculate this based on the computations. So today we have just looking at one side, left side. Tomorrow we'll look at intervals and look at a few questions. Then we are done with the normal distribution. This is the toughest distribution under the probabilities. But if you get this, then you are well and good to go. I hope I have tried to demystify the mysteries in the simplest possible way. Any questions?
Thank you.
All right, so we end here. Have a good evening.
Thank you.
Thank you.